Hey everybody, I hope that you're doing well. So what we're looking at today is section 2.7, which is going to build awesomely off of two things that we already know how to do. Last lesson, we looked at the three-line method. And we're going to combine our ability to do the three-line method with our ability to solve absolute values. We did this back chapter 2, test 2. Remember, the one big key thing here is when we're looking at absolute values, we always have to break it into the two possible cases. So when we're solving an absolute value, we'll get two solutions, right? And with those two solutions, we'll end up doing the three-line method since we know how to handle two inequalities at the same time. So this is pretty interesting. It's a nice next step in using what we know to put two things together. So there's one thing we have to get at then. So if I have two inequalities and I want to do the three number line, all we're missing is the and or the or, right? Because that's the important part, is it an and or is it an or? And it's quite easy to tell. If it's a less than, so you have your absolute value of whatever is a less than, or it could be a less than or equal to whatever 13, that means we're going to use an and. If it's a greater than or a greater than or equal to, we're going to use an or. This is easy to remember if you think of the second syllable in the phrase less than sounds like and greater sounds like or, greater than or. So hopefully whatever you can do to help yourself remember that a less than is going to be an and a greater than is going to be an or. So there, I think we have all the information we need to dive into some examples. Okay, so let's look at our first example. So see, we have an absolute value, and obviously this whole chapter, this whole test we were in, this whole section, it's about inequalities, not equal signs. So we have absolute value of 2x minus 5 is less than or equal to 7. Now what I would like for us to start with on every single one of these that we do is to look at what we have. We have a less than, and to write the word that we're dealing with. When we get to our three-line method, we know it's going to be an and. Okay? So remember, whenever we solved absolute values, we had to consider or break it into two cases, right? The first case was just exactly as we see it. 2x minus 5 is less than or equal to 7. So that's always the first case. You just break it into exactly like you see it. And, since that's the word in between them. The other case, remember, we would have to change the sign, flip this to the opposite sign. So it'd be 2x minus 5. And then we'd want some opposite action happening over here. So it was a positive 7. We'll say it's going to be a negative 7. But remember, anytime I flip signs with inequalities, I also flip the inequality to a greater than or equal to. So there are two things that you have to change over here. Okay? So we have to change the sign and we have to flip the inequality. So those are the two cases we will look at every single time. The first case is just exactly like it is, except for drop the absolute value. The second case is exactly like it is, except for flip the inequality, change the number to a negative or a positive, just the opposite of what it was. Okay? And then we picked the word out from the original. Less than means and. So now I just have two inequalities to solve. Let's solve the left one. I need to add 5 to both sides. So 2x is less than or equal to 12. And then I can just divide both sides by 2. Divide by 2, divide by 2. X is less than or equal to 6. And let's do the other side. So let's solve this case. Got to add 5 to both sides. Now that's 2x is greater than or equal to, now be really careful here, negative 7 plus 5 is negative 2. And then I get to divide both sides by 2. And so x is greater than or equal to negative 2 divided by positive 2 is negative 1. All right. Now look at what I have. Let me highlight what I have first. That's an eraser, not a highlighter. Let me try again. Highlight what I have there. I got a highlighter. X is less than or equal to 6, and x is greater than or equal to negative 1. So we already know how to break an absolute value into two cases and solve. We did that. We did that a few lessons ago, or a few chapters ago. So for it was equal signs, but nothing much has changed. Now look at what I have highlighted. Just last lesson, our problems looked exactly like this. Two inequalities with an and or an or in between them. So we're going to use our 3-line method to get the final solution here. Let's see, and the two numbers I have are 6 and negative 1, so make sure we put the negative 1 on the left and the 6 on the right. Okay, and what we'll do is, let's graph the first one on the top line. X is less than or equal to 6. So 6 or equal to means it's a square bracket. Less than means I'm shading to the left. Okay, now let's graph our other one. X is greater than or equal to negative 1. So go to negative 1. Greater than or equal to is a square bracket, and greater than is to the right. All right, now what word are we looking at? We are looking at an and. Let me write and right here on the third line, our answer line. And remember what an and meant. An and means we're thinking about the overlap. Or you're thinking about where are both of these. Do they both overlap on the left side here? No. Do they both overlap in the middle? Yeah, I have black and red graph. So that means that's going to be included in my answer because they overlap. Do they overlap over here? No, I just have red graph. So they overlap in the middle. Now since I start and stop at these, I need to look up the tick mark here and grab the same symbol. Bracket on the 1. Let's see, the 6 used a square bracket also. So now I can just peel off my interval notation. Left to right, it looks like it starts the green at negative 1 and ends green at 6. And use the same symbols. Square bracket on the negative 1 and square bracket on the 6. There we go. So that is the answer to this original problem here. So what x values make this less than or equal to 7? These x values, negative 1 to 6. And we actually already have all the skills. We already know how to break into two cases and solve. I just had to teach you to flip the inequality here. I had to teach you to pick the word, but once you have the word, we already know how to do a three-line method. That was last lesson. So this is pretty awesome. We're just putting together skills that we already have. Let's look at another example. Here's one. 3x plus 6, absolute valued, is greater than 12. Okay, first things first, let's pick the word off. Greater. That's an or. Now, I need to remember to break into my two cases. Okay, and so the two cases will be as it is written. 3x plus 6 greater than 12. Or, because that's the word we have. Now let's take 3x plus 6. Flip the inequality. It was greater, it's going to be less than, and change the sign of the number, so it's going to become negative 12. Okay, and so I got to solve each one. Let's solve the left one. Minus 6 from both sides. 3x is greater than 6, and now I just got to divide both sides by 3. Divide by 3, divide by 3. X is greater than 2. Or, now let's solve the other side. Subtract 6 over. Be very careful with signs here. I have 3x is less than negative 12 minus 6 is negative 18. And then I can finally divide both sides by 3. And x is less than, let's see, negative 18 divided by 3 is negative 6. Awesome. Let me grab my highlighter again to show you what we have made. I have x is greater than 2 or x is less than negative 6. Well, this is just a three-line method. The inequality, oh, that looks bad. I never drew the other side over for the other case. The inequalities, let's see. Got two inequalities and an or. See, I got the numbers 2 and negative 6, so I need to put those on my tick marks. I need to put the smaller number on the left, the bigger number on the right. Okay, so let's graph these. X is greater than 2. X is greater than 2. Greater than without an or equal to is just a parenthesis, and greater than is to the right. Okay, we got that one. X is less than negative 6. Okay, let's go to negative 6. Less than is this way. That is a parenthesis. Okay, so we got that one. Now let's pay attention to what word we're using. We're using the word or. And or means anywhere that I have shading up top on the top two is going to come down to my bottom line. So do I have shading up here? Yeah, I have green shading. So that means that will be in my answer. Do I have shading in the middle? No, neither one is shaded, so it's not my answer. Do I have shading on the right? Yeah, I do. I have some red shading. So I'll put that there. Now, because I start and stop at the negative 6 and the 2, I need to take the same symbols down that I used above. And like when we did three-line method, this one is two separate chunks of intervals. So I need to write an interval notation for this one and an interval notation for this one. So this one starts at negative infinity and stops at negative 6. This one starts at 2 and stops at infinity using the same symbols on the numbers. And what we put, remember, is a union symbol in between those to say both of these belong together to make up the answer. All right, awesome. I hope that you're doing well. Moseying along. Okay. Let's look at two more examples that are different or have some funny things going on. Okay. 2x plus 7 is less than negative 5. Okay. Let's think about this one for a second before we do it. I bet we could think of the answer before we do it. What is going to come out of the absolute value is going to be positive, right? Are there any positive numbers that are less than a negative number? No, they're not. I'm going to guess this one's going to have no solution just because of that. But let's actually solve it. Let's actually go through all the steps and see if we get no solution. So first off, what word is it? This is less than. So this is and. Okay. And we're going to consider our two cases. Our first case, just take it as it's written. Just drop the absolute values. So 2x plus 7 is less than negative 5. Our second case, 2x plus 7. Flip the inequality. So it was a less than. It's got to become a greater than. Change the sign from it was a negative 5, so we'll consider this a positive 5. Okay? And so we can solve each of these. Subtract 7 over. So 2x is less than negative 12. And then divide by 2. X is less than, what is that, negative 6. And let's solve this side. Subtract 7 over. So 2x is greater than negative 2. And now divide both sides by 2. X is greater than negative 2. Okay? So I have solved the inequality part. Now I just need to come up with the answer for this compound inequality. So we will use our three-line method. Let's see, we have the number negative 6 and negative 2. So put the lower number on the left and the higher number on the right. And let's graph them. X is less than negative 6. Negative 6 less than is that way. Alright, let's graph the other one. X is greater than negative 2. So that's negative 2 and greater than this way. And then finally, what word are we dealing with? And. And remember, and meant we're looking at the overlap. Do I have any overlap between red and green on the left? No. Do I have any overlap between red and green on the right? No. Do I have any overlap between red and green here? No. So there's actually no solution. There's no overlap anywhere. Which I told you at the beginning, we would expect that. So if I were to scroll back up to the top, that's because this is always going to come out positive. Is it ever going to be less than a negative number? No. Some people memorize this fact, and if they see one that's less than a negative number, they go ahead and just jump to the solution. If you know that, you can do that on the test if you see one that is less than a negative number. If you don't know that, or even if you're just nervous and you want to work it works out the same to show you what the solution is. So we're fine there. You don't have to memorize that fact. Okay? Now let's look at another example, another extreme one. Notice it's the same problem really, except for I turned the inequality around. So this is going to be, so we got 2x plus 7 is greater than or equal to negative 5. This is going to be a positive number. That's always greater than negative 5. So I have a feeling this one's going to be negative infinity to positive infinity. Every number should work. But let's actually work it to see, not just go off of my intuition. Let's see, this is greater than, so or. So let's break this in our two cases and solve each one. Let's see, 2x plus 7 is greater than or equal to negative 5. And over here we'll do 2x plus 7 is less than or equal to positive 5. So remember, I flipped both of those, the sign on this thing and the inequality here. That's the part most people forget. Subtract 7, subtract 7. 2x is greater than or equal to negative 12. Divide by 2 on each side, and x is greater than or equal to negative 6. Okay? Or, let's solve the other side. Subtract by 7. 2x is less than or equal to negative 2. And then finally divide both sides by 2. I accidentally used the same numbers over and over again, so forgive me. And so x is less than or equal to negative 1. So there, I have a compound inequality that I'm ready to convert with my 3-line method. So let's draw our 3 lines and do our 3-line method. Okay, let's see. I have negative 6 and negative 1. And let's graph the first one. X is greater than or equal to negative 6. So go to negative 6, or equal to means it's a square bracket, and greater than pushes it that direction. Let's do the other graph. X is less than or equal to negative 1. And so at negative 1, it's a square bracket, and less than or equal to runs us this direction. Now, what word are we dealing with? We're dealing with an or. That means anywhere that I have shading in the top 2 will come down to my answer. So I have shading on the left, I have shading in the middle, and I have shading on the right. So this runs all the way from negative infinity, let me try that again, negative infinity, up to positive infinity. It's the entire number line, all real numbers. Which, wait a second, didn't we have some intuition before we did this to make sense of this? Because we are greater than a negative number, this is an absolute value. It's going to be positive. It's always going to be greater than a negative number, no matter what x value we plug in. Okay, so the last two were just to show you kind of some intuition about some things, about when we're less than a negative or greater than a negative if we're dealing with absolute values. Okay, You don't have to memorize those because they still work the same with this way of working things. Alright? But I think it's pretty neat. Alright, so that's all I have for you today. Be sure to do your worksheet in your My Math Lab, and I will see you next time.